APL is an array-based programming language developed by Kenneth Iverson in the 1960s and later with Roger Huey. Its central data type is the multi-dimensional array, and hence it's very useful for workloads involving a lot of matrix math. APL uses symbols predominantly, and it leverages consistent composability and execution rules to enable it as a notation, as a tool for thought.
I think it could
Yeah.
actually be beneficial in unlocking new ways of thinking about your problem in a way that will help you solve the problem better. If you draw an analogy to another domain which has its own specialized notation, like music, for example, the notation allows you to very quickly get a understanding of what's going on.
Hi, this is Will. I'm a YC alum and independent researcher who has worked across e commerce, cryptocurrency, and financial industries.
And I'm Sri. I'm a YC alum and a research engineer focused on natural language processing for search.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. We're two guys discussing edge, fringe, or overlooked technologies over a couple of drinks. Our show has 4 segments. First, we give a high level outline of what the technology is. Second, we talk about what it can do today. Then, third, we let our imagination and optimism take over and see how the world would change if the technology was readily adopted and everywhere. And lastly, if we believe in this future, how can we take a position on it? We can't be experts in everything we cover, so if you got insights on this topic, let us know in the comments down below. And be sure to check out our audio versions on Apple Podcast or Spotify so you can go about your day as you listen. But first, in the spirit of shooting the bull over a couple of drinks, what are we drinking today, Shri?
So we are, at least I am, drinking tea, Bengal spice, it's herbal tea. I realized in previous episodes that I was running out of hipster drinks at the corner store, and I realized that there is a whole other world of beverages in tea. So you'll probably see me drinking some more tea.
What flavor is Bengal spice? Does it? I assume it doesn't
Um,
have tiger in it.
yeah, hopefully not. I think it's cinnamon and cardamom and stuff like that.
I
How about
see.
you?
I wonder how they decided. Well, so for me, I got Trader Joe's Winter Wassail Punch. And I don't know, like this is a festive beverage blend of apple, cherry, blackcurrant, and lemon juices from concentrate infused with holiday spices and orange peel. Sounds terrible, but I forgot to make a run this week. So I guess you reap what you sow, I guess, right?
Yeah. Cool. So, what are we talking about this week?
So this week we are going to be talking about APL and some of its descendants, J and K, but we'll probably mostly focus on APL. Have you heard about APL before?
I only know that it is a programming language that uses a lot of weird symbols, but yeah, tell us more about it.
Just like the only thing we know about Lisp is that it's a lot of parentheses, right? And so
Yeah.
that's effectively it. And so APL is an array-based programming language developed by Kenneth Iverson in the 1960s and later with Roger Huey. Its central data type is the multi-dimensional array, and hence it's very useful for workloads involving a lot of matrix math. APL uses symbols predominantly, and it leverages consistent composability and execution rules to enable it as a notation, as a tool for thought. And so it's one of those languages that most people would probably think about as an isolang, but in fact, it's something that won Kenneth Iverson a Turing Award. And I guess this show will talk about like why, because like most people don't know it, and they don't know its influences on tools that they may use today. And we'll talk about like what makes it so special and why you would want to look into it today and some of the aspects of the language. So, are you excited? Were you excited when we said, hey, let's do some APL?
I think that I wanted to know more about it because it's something that comes up every now and then on Hacker News and
Hmm.
Lobster. And you're right,
Yeah.
it sort of brought up in the perspective of, hey, this is a weird language. Or people say sometimes that they're going to solve advent of code or some such programming challenge using APL as just as a handicap, right?
Yeah.
That
It's
context?
supposed to, yeah, it's supposed to be, like a really leverage. It's supposed to give you a lot of leverage, right? But I
Yeah,
guess,
yeah,
like, unlike other ESO links, say like brainfuck or something, it's not supposed to hinder you, right? So,
yeah. Right. Yeah, so I was surprised that this is a language that was both seriously used at some point for business applications, and like you said, it is very grounded in a particular style of thinking about computer science and about notation, which I thought, where I had no idea. Because if you look at it from the surface, and we'll probably, let's just get it out of the way
mhm.
so that we don't dwell on it too much.
Yeah.
This looks like a bunch of gibberish. It looks
Yeah.
like literally hieroglyphs.
It looks like line noise effectively. Like, if you thought like other languages that you were unfamiliar with look like line noise, like APL, the only thing I knew about it in the beginning was it was a programming language that required you to buy a whole new keyboard because
Yeah.
your like typical run of the mill ASCII keyboard just wasn't going to cut it. And so I was like, that's weird, but I didn't know much else about it until, I guess, until we had to do this episode, honestly.
Yeah.
So yeah, I think that's the first thing to get out of the way. And I think the notion of weird symbols really sets up a shallow gate to deter new users in the current mainstream culture of programming. Much in the same way that people are put off from lists because they see that it's a whole bunch of parentheses. And that's really a shame because when I looked into it, I was like, "Oh, there's some really interesting ideas in here, especially about language itself." And it was once quoted by, God, who's the first Turing Award winner? That if a programming language doesn't change your mind about how you think about programming, then it's not worth learning at all. And APL definitely changes your mind about like how you think about programming. Because I think the pitfall that we fall into if you only know mainstream programming languages is that you think you know what programming is. And in every era, like, people thought they knew what programming was, and they heartedly and handedly rejected what was the next thing that programming would look like. I mean, like, assembly programmers like hated compiled languages, right? And it's the
Yeah.
same thing when like interpreted languages came around. And I'm sure someday like we'll call people that do prompt engineering programmers. And
Yes.
there's a similar sort of hate, including from us, right? Like, because we joke that prompt engineering is the shortest of
Is a
all
fad.
careers, but yeah. And so we'll see, right? We'll see. But definitely, like, I think APL is rightfully so. It changes your mind of how programming could have been, because then you when you see a lot of these different variations of what was tried in the past, um, you can take the good ideas from there, but you also recognize that, oh, a lot of the design choices we have in our programming language is completely arbitrary, or they were bad decisions to begin with. Like the guy that invented the null, he's just like, that was my $1 billion mistake. Literally, I've wasted like billions of dollars of people's time in the world. So
Yeah. Yeah. That, by the way, that quote comes from Alan Perlis.
yes, Alan
Now that you
Perlis.
mentioned, yeah,
Yes.
yeah. It really is a language which is mind bending because in the pregame we were both discussing that we had tried APL on this online tutorial called tryapl.org, which we'll put in
Which
the
we'll
show
put in
notes.
the show notes. Yeah.
Yeah, but and I recommend that people try it because it is just such a bizarre sensation I felt as an experienced programmer who dabbles in obscure technologies as a matter of running this podcast
Right.
to use that, to go into that site and realize I have no idea what's going on. Like, this thing is completely different, a completely different way of thinking about how to write programs than anything that I've actually written for my job or anything like that. And if
Mhm.
you look at a lot of the links that are posted on Hacker News, a lot of it is blog posts where people say, "Oh, I used APL and it really changed how I write my programs for my day job."
Mhm.
And it's there's a certain way in which APL forces you to think, which I think could be characterized as data oriented, because the core operations of APL are taking in, like you said, multi-dimensional arrays of various types and then morphing them, changing their shapes, or applying some operators into the cells of those arrays, and much more. But it's a very different way of thinking about programming. There's a lot less emphasis on writing code. Your mind, at least for me, was much more focused on, okay, what data do I have, and what is the next thing I want to do with it, and
Mhm.
iteratively working your way towards a solution.
Yeah, for me, it once I was reading it, I did recognize a whole bunch of things that seemed slightly familiar, which was a little surprising to me. Like the REPL in which you iteratively chain together computation reminded me of Lisp, where you kind of iteratively do that. Um, and it also reminded me of data pipelines and data transformations in which you do this sort of thing. And because I've used MATLAB before, like MATLAB is also an array-based language. I used to have to use that at work. So in that sense,
I'm sorry.
like s- I mean, MATLAB is good at what it's good at, but with everything else, like I've seen terrible, terrible MATLAB code because MATLAB is primarily used by scientists and they are
Yeah.
not programmers. In addition, with some amount of familiarity with functional programming, you start to see some of the same ideas in there. But I think what APL does is that it structures and puts it all together in a neat package that is consistent and therefore easier to learn. And also, it kind of fits together in what people would say elegantly because it's kind of like all the pieces fit together. Have you ever seen that subreddit where it's all things that like fit exactly into the space
Hmm.
that
Yeah.
they're
Yeah.
in? It feels
Yeah.
like that. It's like oddly satisfying is what it feels like. So
Yeah.
so I think that's kind of the feeling that I got when I was looking into APL.
Interesting. Yeah. That is not surprising because it was designed with this in mind.
Mhm.
Maybe this is a good opportunity to go into the inventor Kenneth Iverson wrote this paper called "Notation as a Tool of Thought," which really lays out, I felt, in a very structured way, what what he was trying to achieve and the design goals of the APL, the language.
Mhm. Yeah, and I would say that also as an interjection, the notation as a tool for thought essay was I believe the very last thing he wrote on it, so it's kind of a reflection of his
Hmm.
work back then. The very first one, if you want to go back to the original manuscript, it's called a programming language because that is what APL stands for. Surprisingly, it stands for a programming language. Um,
Wow.
and so I think in the going back to the essay on the notation as a tool for thought, that's a reflection of his work on APL and really what he was driving at. Because like when he invented APL, it was written as a spec of the programming language without knowing whether it could be implemented in machines at all. And Alan Kay has said that that's to his benefit and one of the strengths of APL because I think a lot of the languages that were invented previously always had an eye towards execution efficiency, and therefore would be, I guess, used more because people wanted things to run fast. I mean, it's the same true today. But as a result, you have languages that take into account the complexities of the machines of yesteryear, and those kind of stick out like a sore thumb, whereas APL does not. And so it's just like the essay by Richard Sutton called The Bitter Lesson, which we can link to in the show notes, that we mentioned in our previous episode on ChatGPT, which you should check out if you get a chance. That you should take compute, massive compute, into account in the future, because that's effectively what Kenneth Iverson did in the 1960s. That I'll invent a language, worry about the notation and how they compose together, and we'll have somebody else figure out how to like write it into an executable. And so that's one advantage there. But then on the flip side, I would argue that because of that, people always try to get things that are usable practically. And so I think that's probably why our current modern world is run by C and its derivatives rather than Haskell and APL and its derivatives, right? And so
Hmm.
those things are only slowly clawing back the territory that they would have gotten otherwise, right? And so
Yep.
it's through podcasts like this where we discover things that were invented like what is this now, 50, 60 years ago by now. So it looks like the contemporaries of APL, if we say give or take 5 years, would be things like um, assembler, Fortran, COBOL, Lisp, Basic, and I guess that's about it. Yeah. So I think the
Hmm.
main at that time is probably dominated by Fortran and COBOL, I would say, and Lisp maybe, but I think my impression was that Fortran and COBOL were the big ones. Maybe
Yep.
Algol. Yeah, Algol was around back then as well. So I would say Algol, Fortran, COBOL. So in so then back to the essay on the notation as a tool for thought. Um, uh, he lays out like five major points as to what he means by that. And just to outline it here, it would just be the ease of expressing constructs arising in problems, the ability to subordinate detail, uh, suggestivity, which means that like answers to one problem would give you hints about answers to another problem, economy, which he means by the terseness of the syntax, and amenability to formal proofs. And so we won't cover all those in details, but I think for the purpose of this podcast, it would be worth covering the first one, which is the ease of expressing constructs arising in problems, and just kind of like how APL does that. And I think
Hmm.
which is like what the feeling that you get that like things just kind of slot nicely into things. So I think the first thing is that APL is pretty consistent. I think for one, when you write compilers or even just like write a really simple math calculator, you have to take like operation order preference precedence into account when you're evaluating expressions, because math wants to, was it PEMDA that you learned in like
PEMDAS.
grade school? Yeah, PEMDAS,
Yeah.
which is like parentheses, exponents, multiplication, division, addition, subtraction, in that order, right? And
Hmm.
so that leads to some confusion, whereas APL says does away with that and says no, everything is evaluated from right to left, no exceptions. And so that makes it easier to parse what the APL programming line is doing. So I think that's one thing. Uh, Even though APL borrows a lot from math notations, like math itself has a lot of inconsistencies. Like, for example, negation and factorial are on the opposite sides of their argument. Like, I've never really thought about that much before, but I'm like, oh, yeah, that's true.
Yeah.
And then uh, exponentiation doesn't have a symbol, so you can't really like write it out as an operator. Like, instead,
Hmm.
like the exponent is just raised and made smaller, right? And
Yeah.
then magnitude has two symbols, and then they're on both sides of like whatever the argument is. And so APL does away with a lot of this and just says everything has to be either an inline uh, prefix or an infix single symbols. So factorial would be exclamation point B, and then raised to the power is A star B, and then magnitude, which is just bar B. So this matters a lot when you're trying to compose functions together if you have a consistent way of saying this is a function and these are its arguments, right? Um, and so I think that's one of the major things. And so besides this inconsistency, uh, another thing that APL does really well is that it doesn't matter if you're operating on one number or a lot of numbers. So, for any of you that have tried to use uh, matrix multiplication uh, or implement it or use it in a library in languages that aren't array based languages, you can tell that the programmers usually just kind of hard coded it to like two-dimensional arrays, and when you need something for three, like all of a sudden it breaks, or god forbid you need like 4 or 5 dimensional arrays, like it just doesn't know how to handle that. Whereas APL handles that gracefully, as well as any number of like array based programming languages, or even like I guess the pandas packages should technically be able to handle those as well, that is used in Python. And then lastly, the terseness of APL comes from its thoughtful composition of functions and what they call operators. And the analogy that they draw is if numbers are nouns and functions are verbs, then what they call operators are adverbs, and operators um, modify verbs. And so operators modify functions. But for those of us that come from functional programming, operators are effectively higher order functions where they don't modify a function, but they can change where you're targeting that function if you're operating on a lot of numbers, like an array of numbers.
Hmm.
So, for example, in an array, you might have an array of 10 things. And a typical higher order function is, say, reduce. And reduce takes a function, which in this case we might call a verb, and then reduce is the adverb in which it says take this function and apply to every element in the array, and then we're going to accumulate the results of every one of those applications of the function into a single result. And so that would be an example of an operator. And so the typical ones we know about in functional programming are things like reduce, or I think they would call it fold. And
Hmm.
usually in Haskell, I think there's a left fold and a right fold. And then there's also map. And APL also has these things, and they call it reduce and scan. Um, and so, in order to do a summation of vectors, then you would just say slash, which means reduce, and then put a plus. And so that's effectively like reduce with a summation function inside the reduce. And then the vector that comes after it is the argument. Um, and so that makes it really terse. So you can imagine like a symbol as an operator, like plus, plus is the verb, and then you modify it with a slash in front of it, and
Hmm.
that's all you need to do.
Yeah. One other way that I've seen this idea being described, if you're not familiar with functional programming or Haskell or things like this, if you're familiar with Python, Python has list comprehensions, which are basically a way to implement things like map, certainly map and filter, And Python does have a reduce, but it's not available in list comprehensions. But basically, APL is like a whole language where every single function is doing list comprehension. And the whole language is built off of list comprehensions, except that if you try to do list comprehensions in Python, it's very verbose because every single time you have to say, f of x for x and y. Whereas in APL, that's all implicit, and you just say f of x, where x can be something that has one value, a scalar, or it could be a list of things, a vector, or it could
Hmm.
even be a multidimensional array, similar to how you might find in NumPy or Pandas or something like that.
Right. Yeah, and so for those of you that know Python, we'll link to in the show notes a blog post called "Why APL is a Language Worth Knowing," and you can check it out. And that would describe a lot of the mechanics here for you. Um, but yeah, and so I guess also to move on, that well to also highlight what Shri is saying for like list comprehensions, that comes out of functional programming. Like Python borrowed it from functional programming, and so if you know functional programming, you can understand a lot of the concepts that APL tries to present. But it's just that APL takes it further. Like instead of using loops, like functional programming is the traditional like lambda calculus functional programming does away with loops and says let's use recursion, whereas APL says like let's do away with loops, but we'll do kind of these functional operators and we'll make it terse and composable. And that's kind of what you get. And in the literature, they have a term called tacit programming, which is what we call point free form in functional programming. And that has to do with currying, which we won't get into because it's not a podcast about currying. But if you want to look it up. And it's basically a way to define functions without being explicit about the arguments that it takes. How could that work? We'll link to something in the show notes so you can check it out. It's kind of neat. And so I think these are kind of a smattering of basic ideas that we found in APL that gives it the ability to be very expressive and terse, and what earns it as a language that can be a notation as a tool for thought, because everything that we mentioned allows you to focus on mainly just data and like what you're doing with it. You don't have to like keep track of what loop you're on. You don't have to keep track of intermediate local variables that you have to throw away. You don't have to keep track of like there's just not a lot of bookkeeping basically. And so that's the ideal where you get to focus on like I have some data and then I want to change it to this thing, right? It's like
Yep.
data pipelines where you can write it all in one line. And so for people that like Bash, I guess, or awk, then like APL should be, yeah, like APL maybe really missed out by not being the command line calculator for Linux or something.
Wow, that would be really trippy. Uh, and yeah, yeah, I think that this really clicked for me when watched a few videos of somebody live programming a demo application in APL,
Hmm.
because the way that they narrate it is um, as a data pipeline, where usually you have some input data and they say, well, okay, now I have this, and I'm going to, whatever, take the sum of this row, and then now I have this, and then now I'm going to apply this other operator, and now I'll have this. And they just
Hmm.
they do it in this kind of sequential way. Basically, the way
Yeah.
in which your mindset is you're focused on what do I have now and what's the next thing I need to do to it to get it into a shape that is closer to my goal. And you do this by simply adding oftentimes a single symbol or a few symbols that will transform your data. You're not writing a lot of code. Your mind is mostly focused on what shape of data do I have? What shape of data do I want? What's the glyph that I need to add in order to get there.
Yeah, exactly. And so I think that's why people have such a good time with APL. And if you search on Hackler News, of which like I found a couple of testimonials from people that were alive and using it back then, they do say that it made them so productive, and people remark that it must have been like flying a jet airplane back when everybody else was flying biplanes. Yeah, like people, there was a guy that used it in his college course to solve. I guess it was the what is it, the Aqueen problem, Aqueen's
Mhm.
problem, and like he figured it out, turned it in, and then got a D because the professor didn't understand his solution. And then he went over the professor's head to the head of the department, which was the guy that did like APL. He got an A plus, and so, but I mean that goes to say that use APL with caution, I guess, or with some hatred, with in anger, I guess is the term.
Yeah.
But yeah, I mean, I think when you look on HN, you'll see many more testimonials like that. I think the other thing, though, is that people often remark that APL is a write only language because it just kind of looks like line noise. But I think I have some things to say that um, in some of the later sections. So we'll put a pin in that for the moment. But yeah, for now, hopefully, as we're talking, you'll see the canonical example of the game in life in APL that Shri mentioned, where somebody is uh, using APL, like live coding APL, and you can see like why it's interesting. Hopefully, that piques your interest. And
Yep.
so now we kind of gotten through like what is APL and like what it can do. And I think the thing that we do want to touch upon is that people do still use today APL today. And if they don't use APL, they do use some of their derivatives like J and K. And especially K, I know K is used in the financial industry to make lots of money, which a lot of people don't know about, I guess. Um,
Hmm.
but because I think it's not like a free open source software, as most programming languages are nowadays. Mm. And then, real quick, I think I wanted to say that J is a derivative of APL that was worked on by Iverson, and it was mainly because he wanted to have a version of APL that was freely available for anyone to use, and that in his words, can be printed on standard printers, meaning that like you can use it with regular ASCII keyboards. So if you're put off from learning APL just by the weird symbols that are in it, know that Iverson did try to address this in his later part of his career, where he had a derivative of APL called J. And one of the motivations was that it can be printed on standard printers, which in our day is translated to mean that you can use your regular keyboard on it. You don't have to buy a whole new keyboard on it. So um, that is probably good news. Um, and then I think the other thing that I wanted to say was that I was surprised that APL was invented for teaching and writing programs, and eventually, like Iverson got sucked into I think a division at IBM. And as we know, IBM wanted to hire people to improve their business processes, and I was surprised because most of the things that APL seems to be good at is for matrix multiplication. So you would think that it's more like Fortran for numeric computations, but that is not the case. But when I really thought about it, I think APL like language should have been adopted in spreadsheets. And I guess that's also another thing that we'll get to later.
Yeah.
Um, but overall, I think in the part where we talk about like where is this used today, that's my knowledge of where it's used today.
Yeah, and also, just to make it clear, this is a real language. It is used in financial applications. It was used for business processes, and IBM, in fact, shipped a machine in which it shipped with an APL interpreter as and an APL keyboard. So, like, this was not a joke language or a theoretical
Yeah,
language or an ESO language. Like, this was actually making people money in real life
right.
scenarios.
Yeah, 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 and still today with K, so that's no joke. Probably more money than any other programming language has ever made. I don't know.
Yeah.
So I guess like moving on to what what this implies, I guess. Like, does APL have a future? Because like I guess this is we should have said it at the top of our episode. This is more like a retro episode because APL is what 60 years old, and we're
Yep.
still talking about it today. Like, why does it matter?
I think it matters more than I thought going into it. I think it matters in two ways, and I'm sure we'll get into to these.
Really?
Like,
That's surprising because you're like, then why did you pick it? Like, what was your thinking? Because in our pregame, we're like, oh, do you want to do this? You're like, yeah, sure. Like, let's do this one. So
I,
prejudice before.
it wasn't a prejudice per se. I think that I thought it would be a really weird and obscure topic, and
Oh,
I that's those are some of the topics that I enjoy, and so I was like, let's just pick it for that reason, right? And what I learned what I learned is that it's important in two ways. One way that it's important is the effect that it already had, and we've been alluding to this,
mhm,
but if you use a lot of modern data processing libraries like pandas and numpy and whatnot,
mhm,
um, the way that they work is similar slash must be inspired by APL, and I'm sure APL being as early as it was probably did set the precedent for uh, the way that those kind of libraries work, data manipulation libraries. And what I mean specifically is if you use NumPy and Pandas and whatnot, you typically don't write in loops, and you think about applying functions in a vectorized way that operate maybe row wise or column wise over the entire structure of your data, which is
mhm.
oftentimes a table, right? And so I think that is how APL works. APL, I think, is even more powerful than the libraries that we have today, but it's very clear that it has a strong influence.
Yeah, yeah. I think the type of operations that you can use on it um, very much borrow from APL, but I think it does lack APL's elegance in the because it takes the functional composition from the algo class of languages and then kind of layers it on top, which doesn't it kind of loses some of its elegance and composability that makes it work well
Yep.
when you do that. And so that was
Yeah.
point number one. What was the second one?
Yeah. I think point number two was more of taking inspiration from this idea that we could think about programming in a different way, which uses a terse notation and applying it to, I don't know, different domains, right? I think you mentioned spreadsheets. I
Hmm.
also want to go into machine learning as well, and data pipelines.
Yeah,
Basically, there are a lot of different applications in which we're writing a lot of code, and a lot of it is boilerplate, but
yeah.
they are basically just different ways of manipulating data. And what the weird thing that I find is that it feels like there's an aversion among modern programmers against having to learn anything, learn a new type of notation, or think in a different way. Like, there's
I
just like so
don't
much
know.
emphasis on developer ergonomics, and I'm like, well, maybe we're giving something up by not investing in learning notation that can boost to our productivity.
Yeah, I imagine that this is what Allocate laments because he's like, even today, like programming language literacy is like getting lower and lower. I guess you could draw the analogy that yes, you want developer ergonomics, but to a point, right? You can't you can't have like an exercise program where you're like, okay, just take it easy, right? The whole point is to have you work your mind a little bit, right? Like
Yeah.
you can't you can't gain muscle if you're going to take it easy all the time. Like you have to do a little bit of work to gain that extra something so that you can think about your problem a little bit more different. And so the willingness to pick up new types of notation or like a different way of thinking about programming, that's what you find that there's a resistance to, right? Because it's like seemingly so weird, or maybe like, how is this going to help my career? Am I going to get paid
Yeah.
more? I'll If it's no, then see ya, I'm going to go kite surfing this weekend.
Yeah, exactly. And I think beyond just like it's good for you and it will help your mind or something like that, I think it could
Yeah.
actually be beneficial in unlocking a new ways of thinking about your problem in a way that will help you solve the problem better. And if you draw an analogy to another domain which has its own specialized notation, like music, for example, the notation allows you to just like parse very quickly a piece of music, or in this case a program, and then very quickly get a understanding of what's going on, or at least that's the hope, is that
Well,
by condensing things into terse symbols, i- assuming that you're an educated person who knows about those symbols, you will very quickly be able to get the lay of the land, or to quickly get be able to get the ideas out of your mind and into the notation.
yeah, and I think that's why like notation, the right notation is so powerful as a tool for thought, which I think is what Iverson was getting at. Like that, if you have something where you can just have the details of the problem that you're working on, it would be small enough to fit on the page, and then you can start to see patterns in how you solve this one problem has a relation to how you solve something else, which is what he called suggestive, which I mentioned earlier.
Mhm.
But like that's the sort of thing that kind of helps your thinking, right? Because like the reason why people say like writing helps your thinking is not just because it helps with the memory problem. Like imagine if you had to like memorize everything that you wanted to say, like you can't write it down, right? And so like it doesn't just help with the memory, but like when you see your argument laid out on paper for some sort of essay, you start to see like a structure of some sort, right? And the structure that people teach you in high school is just kind of that introduction, three supporting arguments, and then repeat your repeat your introduction. Like that's the basic of all like structures for an argument of something. But then there's others. And so as you write more, whether it's emails or something else, right? Like email has its own
Mhm.
structure. Like there are people, I have friends that purport that there's people that write awesome work emails to the point where they're like it's just so blindingly good, right? Like
Huh.
or like intro emails, that those have their own structures, right? There's like little cultural things that like people do to make it easy to get other people to do stuff for them. Like these things all have structures to it. And in the same way, like when the details are subsumed into the understanding of the notation, then that allows you to start to see structure of the problem at hand rather than all the details. And I guess that's kind of the holy grail of programming, right? And so
Yeah.
so I think that's what we're arguing for in like why this is important, or like how it changes your thinking about programming and how it'll help you with the work at hand, rather than something where it's like we're not, our argument is not, oh, like learning Latin is going to help you appreciate the world more, which I mean is cool in its own right, but that's not what we're saying here.
Yeah. Yeah. Exactly.
So given that we're here, we're arguing that APL is good for helping you think about different problems. Like, where else can we go from here? This is like a 60-year-old language, and presumably we either mined it all for its ideas, or there's still something left, or maybe like something new has changed that gave it somewhere to go, right? And so I can think of like a
Yeah.
couple things that might be interesting here. I think one is that APL is an array based language, and it can operate on matrices of numbers of high dimensions. And so, one, I'm pretty sure like the current implementations of APL are really old. and that they don't take into account the multi-cores that we have today. And so if you can write it in APL, it's very likely that it's easily parallelizable. But I'm pretty sure that current implementations don't actually leverage that to exploit the multi-cores that we have today. And so it potentially could be a really interesting and perhaps profitable language for doing this sort of thing, which leads me to my second point, is that whoever was on the APL train in the mid 2010s should have been like waving their hands, writing a plugin for Jupyter notebooks saying, we can do ML, we can do ML too, right? Like
Yeah.
this is right up our alley. Like forget pandas, like use I don't know, whatever J, right? Use J or like the
Yeah.
APL derivative, because like you can write it terse, it's fast, it's parallelizable. Like this is, I think, totally a missed opportunity.
Yeah. So I think there are a couple of fruitful things there. But basically, to pull back a little bit, the reason why APL could be relevant in different domains today is that, like we mentioned, at its core, it's describing a data pipeline, right? Like it literally the way that you read APL and the way that the operator precedence, or there's no operator precedence, the way that it's structured is that data flows basically from right to left, right,
Yeah.
through the different operators. You can
Hmm.
think about it that way. And there are a lot of different domains that are increasingly prevalent today, which are data pipelines. One is things like Apache Spark or Beam. So people are using
Right.
these libraries to process big data, and the way that you structure a Apache Spark or Beam program is that you specify a data pipeline and you say, read this file, and this file could be terabytes large, and do these operations on it. Apply this function, reduce it, et cetera, fan it out
Yeah.
in
Hmm.
all these different ways.
Yeah.
And you let the runtime take care of the actual mechanics of reading the data, parceling it out into smaller chunks, sending
Hmm.
it to workers, et cetera, et cetera.
Hmm.
And so I wonder if, like you said, if you had a modern version of APL in which you just write the pipeline declaratively and you
Hmm.
let the underlying runtime take care of actually doing all those other mechanics of it, whether you could process big data like very trivially. Because the thing is that with like these other libraries, it's a you have to write all this boilerplate and whatever to set it all up. Like I wonder if you could just have a REPL that's like this big data REPL and you just write a few symbols and just get it done.
I think maybe yes. I do know there were attempts to do declarative data pipelines with things like SparkQL. Like they decided to emulate the declarative language of SQL,
Mhm.
because like guess like it's the language of data queries, and so that seemed like a natural way to go. But I think
Yeah.
definitely like APL or some APL like language may be a good fit for this sort of thing. I think you really have to, I don't know. Like it would have been an easier sell if there was like no other choice on the market at the moment, and like everybody just had to learn APL as a result. It would be an interesting experiment, I think. Like, is an APL language more expressive than an SQL like language in doing data pipelines? Maybe. It's a very strong possibility for certain types of workloads, I would think. Yeah.
Yeah, the other thing which I also was fascinated about is applying APL to machine learning,
Hmm.
because it's also a type of data pipeline.
Yeah.
Like a lot of it is just piping data through different operators, and especially with neural networks, you're piping data through different layers um, of a neural network, which is just math functions.
Yeah. I mean, Andrew Kaparthi has a repo called MinGPT in which he demonstrates the core idea of GPT in like what 200 lines of Python, I bet
Mhm.
somebody could reduce that to like 5 or 6 lines of APL, maybe.
Yeah, maybe not quite 5 or 6, but certainly 20,
Right.
because I saw a great paper. We'll put it in the show notes where somebody implemented a convolutional neural network in APL, and they did that in 10 lines. And I think they could have code golfed it to be shorter than
Right, they
that, but
could have cold
they
golfed
did
it,
like
but this is like with enough leg room in the APL airlines, right? So
yeah, yeah. They're like, yeah, like that was a nice, like very readable APL program as far as I could tell,
Mhm.
because it was meant to be instructional. And I don't know. I mean, people might not be necessarily familiar with convolutional neural networks, but they're not trivial because they involve this idea of running filters over like iteratively
Yeah,
over these like two dimensional
yeah,
grids and
you have
whatnot.
a two-dimensional window that is, like, being scanned across another two-dimensional grid. So, it like,
Yeah,
getting all the indices right can be problematic because you have to take into account the edge cases of when the window is at the edges of your image and stuff like that. And so that can bloat whatever code that you have to write. And one of the good things about APL is that they have sane defaults for some of these edge cases.
yeah, exactly. So I thought that was interesting, and they benchmarked it also against modern frameworks like
Hmm.
TensorFlow, and
Hmm.
apparently there's some version of APL that can be compiled ahead of time rather than purely interpreted, and it's competitive with something like TensorFlow. So I don't know. It's interesting. I'm not sure why somebody would prefer it, other than maybe terseness, but it seems like it's a good
Well,
fit for the
I have an
domain.
answer for that. I mean, like the if you I guess it goes back to suggestivity because like if you can spot the if you have everything in a couple lines, presumably like you can like look at it, inspect it, run parts of it to understand it, but then you can see the overall pattern of solving this problem. And so you would be able to look at other problems and see, oh, can I take the same pattern over here and apply it over there? Because you can imagine like future programming languages, including something like a neural network as part of their runtime library. And so if you can modify that while it's running just to try out new models, that would be pretty powerful too. Like normally you wouldn't do that, but it's akin to like being able to um, change the operator precedence of your language or change the way that functions are called or something like that. Like change the scheduler.
Yeah, 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 I see that. And yeah, and I think it could be good also just as a instructional tool because
Hmm.
if you read a lot of machine learning code, it it's very hard to parse. It's very verbose, and uh,
As
common
simple as
things
they
take
tried
a
to make it, yeah.
yeah, yeah. It's like common things take a lot of characters. Like you have to be like, torch dot multiply or torch dot
Hmm.
whatever reshape and
Yeah.
whatnot, like
Hmm.
doing all these matrix manipulations. And
Hmm.
it'd be nice if you could just focus more on uh, more on the data and less on the boilerplate and less on the framework. And
Hmm.
yeah, in the case of like the min gpt and those kind of instructional tools, it could be good at least for beginners to neural networks to learn how to implement the core functionalities, the core modules that way, and then later on, okay, of course, you might use a production framework.
Yeah, and also, I mean, I think it's good marketing for APL. Like if somebody like is in charge of some sort of AP, like still there are APL companies today. Like if you want some marketing to come your way, like just try it. I'm sure you can code golf that into getting some attention on Hacker News and Lobsters.
Yeah. Well, actually, there are people who do this. We'll put it in the show notes. There's a good YouTube playlist called "Learn APL with Neural Networks," where somebody uses APL to solve MNIST, which is digit recognition, and then there's
Hmm.
another paper which implements CNNs using APL. Yeah, we'll put those in the show notes as well.
Yeah, and also there is a podcast that only talks about array-based languages. So if you thought we were niche, like go check those guys out. I think it's
Yeah.
called Array Pod or something. We'll link it to in the show notes. But yeah.
Yeah.
And so I think well, what about some of the other things that you think you could take APL like in other directions?
Yeah. I mean, we were talking before the show about applying APL concepts to more modern types of data. So, in the modern world, we're typically not working with nested arrays of numbers.
Hmm. Yeah.
Our data today is much more like JSON is the standard sort of lingua franca of like how data is interchanged today, and JSON is a notation which has dictionaries with keys that map to some values, and the values can be scalars, but they can also be arrays or dictionaries themselves. And so I don't know why I explained that. Most people, most modern programmers know how that works.
Right. Like Captain Obvious, yes.
But basically, it's not that different than what APL was optimized for, I think. Like I think that if somebody was motivated, they could come up with an APL like language that operates over this type of nested JSON data rather than the old style of arrays.
Yeah, and I think you mentioned that also, and I was thinking, oh, isn't this JQ in spirit? Because
Yeah.
it is like a command line, single line JSON manipulation utility. But then I think what you're saying is going one step further because Iverson actually put out a spec of a consistent notation and composable like way to put functions together in order to manipulate multi-dimensional arrays of numbers. And by the way, as an aside, APL can also manipulate strings, but that's it. Don't it's not just a numeric computational sort of thing, but like a lot of the operations are about multi-dimensional arrays. And so I think what you're saying is let's have something like that, but for hierarchical data such as JSON, because a lot of what we manipulate is not just arrays, but oftentimes like trees and sometimes graphs and stuff like that. And so
Mhm.
having that, especially when the predominant text data interchange on the web is JSON, which is hierarchical, that might be very useful because also a lot of the work for CRUD apps and a lot of the apps that you see today is just shuttling, like querying for some data from the database using SQL and then piping it into some sort of like JSON format and then parsing it on the other side into some sort of like object hierarchical thing. And
Mhm.
then throwing into your hierarchical like component React, like whatever your DOM thing is, which is also hierarchical.
Yeah.
And it just seems like a lot of wasted work when you like take a step back and look at it. And so really it's kind of like why are we doing that? It's because we don't have a good story of doing this across the network. And so I guess as I'm talking about it, people have thought about like remote SQL, but like remote
Mhm.
APL, like APL across a network or APL across like a distributed data query. That that might be not just interesting technically, but it might be helpful to get like cut out all this boilerplate that we have to do.
Yeah, that is interesting. Even if you don't think about it as applying it over some type of networked data structures, there is a lot of boilerplate work of just like looping over some response from some API and then
Yeah.
co-locating some other data together because they appear in the same React component and then sending that down the tree like you said. And so we're just parceling out data, reshaping it in different ways, aggregating things differently. And yeah, it just feels like why don't we if this is the core 90% of what people are doing, and then there's 10% that's actually interesting. Why don't we condense that 90% into something really terse that just gets the job done, right? Like, why does that need to be also 90% of the lines in our code base? Maybe we can just compress that. And I saw a really great talk about data oriented programming. We'll put it in the show notes, but
Hmm.
this person was explaining that data oriented programming is a view of programming that says the only purpose of code is to transform data. Like, nobody actually cares about code. In fact, it's a liability. What you actually
Hmm.
care about is you get your data from one place to another, or in one shape to another. And so I do feel like for most CRUD apps and most web applications today, that is the case. So I think we could have a APL like language that lets us do that concisely.
So then why not SQL? Like why I know this is an episode about APL, so we harp on it all the time. But like
Yeah.
say to play devil's advocate, like why not SQL as a like a declarative language to just get stuff from the database here? Or I guess to call out one of our previous episodes, why not data log for that matter, right?
Yeah, I mean, I think those two are separate, right? There's
Hmm.
how do you query data, and maybe you would use SQL or data log or whatever. But okay, let's say that you use one of those tools and you get back, but let's say that you get a JSON structure back.
Yeah,
What are
yeah.
you going to do? Now you need to feed it into your React tree. And chances
Yeah.
are your React component tree is
Hmm.
not exactly the same shape as your JSON
Yeah.
data, such that you can
Hmm.
just pass it straight through. You're doing some loops, you pick a few
Yeah.
keys here, you pick a few keys here,
You have
maybe you
to
merge
filter
two
stuff
RPC
out.
responses.
Like the user shouldn't be able to see this sort of data, that sort of thing. Yeah, yeah. So then, yeah, I could buy that. Like that would be something that would be better served with an APL like language because even though like um, SQL has like filters, has like selector, like it's mostly about like querying for data. It's not actually about like transformations. And so there are
Yeah.
transformations that are implied inside of the declarative language of SQL. But like if you're thinking about things in steps of transformations, then that may be a better argument for something like APL then.
Yeah. Yeah. And I do also want to call out that probably the closest that I've seen to what we're talking about for JSON structured data is things like underscore and Lodash, which
Oh,
have
okay.
quite a dizzying array of functional type operators which
Hmm.
operate on collections and arrays and whatnot. So it's there, but I think there is something to be said about terseness as well. If you are a web programmer and you're just doing this day in, day out, maybe it's worth learning some notation so that you can do this in a few symbols rather than constantly typing out long function names.
Right. And so
Hmm.
I would agree that we need something for that. Um, are there other things? Because I was thinking that it's a really missed. I was saying earlier that it's a missed opportunity that spreadsheets themselves
Yeah.
don't use an APL like language because it just seems like such a great fit. Like the amount of space that you have for an Excel function is just one line typically,
Hmm.
and they decided to use an algo like syntax, which is not exactly conducive. And so you should be able to use that for spreadsheets. And, Excel users aren't typical mainstream programmers, so they don't know any better. So if because they aren't going to resist, right? They're going to be like, I
Mm.
guess this is just what you need to do functions in Excel, so they're willing to learn it. I think it's a missed opportunity.
Yeah, not only that, they are also highly motivated. There are
You're
people
right.
who are really, really good at Excel functions,
Yeah,
and
yeah.
they can whip up all kinds of crazy things that you would think that a spreadsheet program wouldn't be able to do. My point is that people are managing to do things and
Mhm.
willing to learn whatever weird
Yeah,
formula
yeah, yeah,
language that
yeah,
Excel has. So why
exactly.
not learn APL? Yeah.
Yeah, I would say it seems like a good fit. I wonder why it wasn't. Maybe my guess is just that whoever was on the Excel team probably just didn't know about APL, is my guess. I don't know.
Hmm. Yeah. Yeah.
Maybe
Uh,
they looked at it and they're just like, nope. They just noped it out of there.
yeah. I was thinking another way in which you could combine APL and spreadsheets is that rather than having the cells in line with some kind of APL formulas, you could have some type of environment in which you have the data in a grid in
Hmm.
sort of a spreadsheet format, and then on the side you have a REPL or something in which you manipulate it with APL commands, and you can watch the data transform. And at the end of the day, then you would get not only your final data in the shape that you wanted, but then you also have a program on the side which now you could apply to other spreadsheets.
Oh, that's kind of neat. I think you also mentioned that, like, instead of just the spreadsheet, like, what if you just had an entire immutable database, and then you could just use APL to apply step by step the data transformation that you want.
Yeah,
Um,
yeah,
maybe a more common case is like you let it ingest some sort of CSV and then you apply APL to it, and
yeah.
then it spits out a CSV that you want. But then I think you mentioned that the KDB plus is something like that. Is that correct? I haven't looked into it, but like KDB
Yeah.
is integrated inside the K language, which is itself a derivative of APL. Is that correct?
Yeah, I looked into it very briefly. It seems like this is a real product. So, like we mentioned, a lot of the APL implementations are commercially licensed products.
Hmm.
And there's a company out there who is primarily targeting financial use cases, like we mentioned. And they're selling uh, the KDB Plus, which is the K language that has a um, columnar, I don't know how to say that word, yeah, but like
Column
column based
orientated database.
column
Yeah, column
database.
orientated database. Yeah, yeah.
Yeah, yeah, yeah. So I think that is used for financial applications, primarily for time series applications. So people are probably using this to analyze stocks and have some trading algorithms and whatnot. So yeah, that's a thing
Uh-huh.
that exists.
Yeah, yeah. I remember reading something about K from Hacker News, but I can't find the resource to it, that you can implement like a simple text editor in K in just a couple lines of code. And so I was at the time I was surprised. I'm like, this looks like line noise. And yeah, I I haven't revisited that. I think there we'll put it in the show notes, but I think there is a tutorial for K where the repo takes you step by step through the different concepts of K. And so if you want to learn K, I mean that's also available. But you have to buy a license, I think. I think there are free versions for limited, but yeah, basically it's a commercial language, which is rare nowadays, right? But I guess they're able to do it because they sell to financial industries, and people are willing to pay for whatever they makes them money. So that's where they're at.
Yeah, actually, that was cited in Hacker News as also a limitation, in that if you wanted to use it for anything that wasn't a very high ROI use case,
Uh-huh.
it was why would you pay $1,600 to, I don't know, munge some
Right.
text? So that definitely hindered its adoption, and it seems to be a theme because small talk in our small
Hmm.
talk episode, we talked a
Yeah.
lot about how one of the reasons why it wasn't adopted very widely was that it was also a commercial programming environment. So there doesn't seem to be a very good track record of commercial programming languages really taking off.
Yeah, and you have to remember that this is in the era in which people were trying to do this sort of thing. Whereas I think from the 90s onward, people are like, I guess we'll just release stuff open source and make our money upstream somewhere or something like that. Yeah, I don't know.
Yeah.
Or I
Yeah.
guess for the programming language designer, it is I'll get hired at a big company that uses this, right? So,
Right. Yeah.
yeah. Yeah, so I think those are kind of some of the directions that I can see. Are there other ones? Because I think you mentioned a couple other ones. Did you want to mention those?
Yeah. So one argument that I saw being made for why APL could make a comeback, or at least the idea of having a language which has a terse notation, is that maybe in the future people are going to be programming on mobile, and
Oh,
and this is actually come to fruition in that there have been some companies lately who have released programming environments for mobile which are primarily used by young people, Gen Z, as they say, because
well,
they're
also
mobile
there's
first.
right, but also there's that no code movement or low code, no code. And so people have been trying to figure out ways to program on a mobile phone. Also, it's probably pretty enabling because most people in the world have a mobile phone. Not everybody has a laptop, right? And
Yeah,
so
yeah,
if it works or works well to the degree, like your TAM is potentially much, much larger.
yeah. And one of the environments that has really seen some adoption is released by this company called Replit, and the way that they solve the UX is that they have a specialized keyboard, like an in-app keyboard, which
Uh-huh.
exposes common keywords, so if and
Uh,
else and when whatnot, and so
yeah.
that way you're not having to type out very verbose types of code. But yeah,
Uh-huh.
maybe if you're willing to have a special keyboard, well, I have just a language for you.
You're right,
Right?
right. That's a tweet. That's a tweet.
Yeah. Right. So maybe we could just have an APL keyboard on those things,
Right, right.
and
Why not go all the way, right? Because
let's
if you're
go all the
willing to
way.
go there, right? If you're willing to smoke some weed, might as well just go for a methamphetamines, is what you're saying.
Yeah, yeah, that's another tweet we could put. Yeah, exactly.
Yeah, no, I think that's an interesting thought because I think one of the lamentations about the iPad is that it's consumer orientated and that, it's not really it doesn't invoke a creator culture, but instead a consumer culture, especially in our young kids. And maybe it's because we have not figured out the interface for doing editing type of work. And maybe it just doesn't look like what it looks like on the laptop because the form factor is different. And honestly, I'm surprised. Like, when I watch young kids playing Fortnite and I'm looking at the controls as like an adult, I'm like, there's no way I can play this game like this. But then like the young kids, they like warp their fingers so that they're touching like multiple keys at the same time, and they're
Huh.
playing just as well, if not better, right, than I could on a keyboard. I'm like, well, point taken. So maybe yeah, maybe it's doable. Maybe people are wrong that it's consumer devices. It's just that we have not done enough of the UI research into making these happen. Like there's no equivalent of a park for iPads nowadays, right? Like there's no
Mhm.
research lab doing like human computer interaction as far as I know for iPads and stuff like that.
Yeah. It seems like the people who have the biggest problem with APL are experienced programmers because they're like,
Yeah,
yeah, this thing doesn't look
exactly.
like the thing I know.
We
But
just
I
need
wonder, yeah,
programmers our age to die off, honestly, right?
right.
That's the only way things move forward. So that we aren't like at the top of the food chain telling people that this is the way that you should program.
Yeah, and I, going back to your assertion that hey, if people don't know any better, they would be willing to learn this thing. Yeah, it does seem like if you just say, hey, this is how programming works, and especially if you're going to do it on mobile, you have to use these characters because it's just easier to input. I don't know if people are going to be up in arms and say, well, what the heck, because they don't know any alternative reality, and if it solves their problem and lets them do the thing that they want, they'll be willing to learn it. It's only people like us who don't want to learn new things.
Well, and on the flip side, that's the exact same argument for a lot of the conventions that we have today, because like we just kind of take it like that's what we learned, right? People
Yeah.
showed it to us and we're just like, I guess this is what programming is like. And so we just kind of go with it, right?
Yeah, it's true. It's not like I was jumping for joy, being like, "Wow, this is entirely intuitive," and I feel like I know it all in my heart. Yeah, I sucked it up and learned it too, right? Like, yeah,
Right. It
almost any
wasn't
notation is like that.
intuitive, right? Because I was like, well, I guess it's hard because like if it's hard because like I am not working hard enough to learn it, or like I'm just not getting it. It's not like this is like badly designed or something, right? But then like
Right.
now that you're more well versed and like you and I have like surveyed the buffet of like what might have been, like we're like, oh, there's a lot of these designs that are arbitrary. Like we just kind of
Yeah.
picked it up and now they're everywhere. Like somebody designed it, made the decision, and through both like uh it's the sheer luck of distribution and sometimes just kind of piggybacking off of things, like we have design decisions that don't best serve us, that is now pervasive everywhere. I mean, like it's everywhere. Just like QWERTY keyboard is one, right?
Hmm.
Uh, and the
Yeah.
fact that like even like things about like what the middle mouse button does. Like if you're on any other OS besides like Windows and Mac, you're like, oh, that's a weird design choice, but like it's just arbitrary.
Yeah. 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 So yeah, we've internalized a lot of just arbitrary decisions, and if you go to people who have a fresh beginner's mind, as they say,
Hmm.
they may be more open to alternative ways of doing things. And that actually leads me to another potential use case. Speaking of naive intelligences, LLMs. So
Yes.
I think that a lot of people nowadays are interested in using large language models like
Hmm.
GPT-3 and ChatGPT. Check out our episode about that to learn more about
Hmm.
those. But people are interested in using those tools to generate code.
Yeah.
And it feels like people are using them to generate code that humans would write,
Hmm.
which makes sense because people are typically interested in generating code that they can paste into some pre-existing code base, which was written by humans. But I'm curious to think about alternative languages for natively LLM generated code. Like if you are to
Oh
start a
yeah.
completely from scratch code base, and all the code, the entirety of the code is written by these language models, and you as a human simply tell it what to do and then it generates that output. Why would it have to look like JavaScript, right? Because these things don't need human ergonomics. They can
Wait,
just
but then
output
are
anything.
is it meant to be executed by computers, or is it meant to be read by humans as an output? Because then you could argue that why not just output machine code or assembly language?
Yeah, that's true. Because a couple of reasons why. One
Hmm.
reason is that these models have a limitation in terms of context size. Context size meaning that when you
Oh
give
yeah.
them an input,
Hmm.
do this and that, sometimes they need to read the surrounding code in order to know
Yeah.
the
Yeah.
context
Yeah.
of
Yeah.
what the new code to generate. And that has a limitation in terms of the number of characters. Well, great.
Yeah.
APL takes like minimum number of characters possible to
Oh
express
yeah.
this thing.
Yeah. 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 Whereas like on the flip side, brainfuck is just right. It's just the complete opposite of what you would want an LLM to generate, because like by the time it reached the what is it, the 2048 token, like all you've done is typed out LELL and then you can't even spell hello with the number of tokens that you used for brainfuck, right? Whereas
Yeah.
APL, like you get a lot done in the fewest number of tokens.
Yeah, I mean, in 20 lines, you have, like a text editor or
itself,
one
right?
liner. Yeah, yeah,
Or Chat
you
GPT
or
itself,
Chat
right?
GPT itself, right? Yeah, yeah, because you
Right.
express transformers in like 20 lines. Yeah, so that's one advantage, and then I think, although in the future I'm sure context sizes will get larger, one vague idea that I have is that the expressivity of a uh, single token or sequence of tokens is just very powerful, right? So it goes back to the suggestivity that Iverson was talking about, which is that
Hmm.
if you know a sequence or a pattern of APL glyphs to apply in one context, you
Hmm.
see that the ways in which you can apply it in other contexts. And
Yeah, yeah, yeah.
so and these are how these language models also work, because they read a lot of text in their training
Mm.
data, and
Hmm.
they use that and they recompose it when you ask them for novel outputs.
Hmm.
So I wonder if the suggestivity part of APL allows the models to generalize the code to novel situations better than they would a language which doesn't have that property of suggestivity.
Yeah, I mean, the consistency of APL probably really helps with that too. So, to give our listeners an example of what we're talking about with the suggestivity, is that APL has an operator called row, and it looks like the Greek letter rho, and it basically just gives you the shape of whatever vector or multidimensional array that you give it. So, if it's a 3 by 2, it'll give you an array of 3, 2. If it's multidimensional, it'll just give you that. But then if you have the operator row row, that gives you the rank, because it effectively is the shape of the shape, which is what rank means. And so that's a pattern that you can use across all sorts of problems to see the rank of whatever data that you have, which, like, they didn't reapply. There's not another symbol for rank. It's just the shape of a shape, right? And that's what rank is. And so that's the an example of suggestivity that we're talking about here.
Yeah, exactly. You can compose them in novel ways and still
Hmm.
get a coherent output, means that maybe it allows these models to generalize better than, I don't know, some other language in which you couldn't, it doesn't have that consistency, and it has to know a lot more about the specifics or the specific libraries or specific function calls in order to get something good.
Yeah, yeah, it would be interesting to try, because right now with LLMs, we don't know its inherent limitations yet. Because, like, just a couple months ago with the image generation uh algorithms like DAL-E, it was well known that it couldn't spell. But it turns out that if you put in like character level data in it, because so that it becomes character aware, like spelling is actually no problem. And so I wonder if it's
Mhm.
something similar with APL, in that it's not able to generate solutions because it just doesn't have the memory buffer for the tokens, uh and like it or it doesn't have the consistency of a language to help it generate these solutions, because, like, even like mainstream programming languages, there are edge cases. Like, it's not fully specified. Like, most programming languages, as rigid as they seem, have edge cases in which they're completely unspecified. And people
Mhm.
try to fully specify programming languages, but usually those are smaller toy examples. Like, production mainstream languages are have so many edge cases that you don't really know about, because you don't, like, unless you're writing quins or like some sort of like obfuscation thing, you probably wouldn't know about them.
Yeah. Yeah. Yeah, and actually, another thing that comes to mind for why this could be a good language for LLMs is that one property of LLMs is that they can be prompted using this thing called chain of thought. Basically,
Ah,
what it means is that you
ah.
can structure your request in such a way that it makes a plan. like
Right.
where it says, "Oh, in order to solve this problem, I need to do this
Mhm.
first and this next and this next, and then I'll
Right.
get my answer." And hey, that kind of looks like a data pipeline, right? And for each of those
Right.
steps in that chain of thought, if it can map that to an APL function, then maybe it can just solve the whole problem that way.
Right, right. Yeah, I mean, all the things that you're tweeting about this last week have kind of come together because like now you get a coherent picture in the podcast. So I guess dear
Yeah,
listeners, if you're more interested in this stuff, you should follow Shri at Sridata, and he'll feed that. You'll get a live feed of this stuff. You don't have to wait for the podcast, but
yeah,
maybe listen
exactly.
to it for the synthesis, right? Yeah, no, I think that was an interesting thought when I saw you talking about it. Because the thinking was that, oh, okay, like the LLMs aren't sophisticated enough currently for you to give them a high level thing and for them to carry it all the way through. You actually need to break it down for them, albeit not all the way down to the level of a programming language where you're like telling it which bits to put in which registers. But but break down the task such that it's able to kind of do things and guide it through. And perhaps with something like APL, you're able to specify that at a higher level, and then that would be the breakdown effectively, right?
Yeah, and then it can just write basically convert that intent into
Hmm.
APL and solve the
Yeah.
problem. Yeah,
Hmm. Yeah, yeah, yeah. That's an interesting thought, huh? And then you do it on mobile.
and then you do it on mobile. Actually, I was doing in the prep work. I was using Chat GPT to try to explain APL code to me because
Oh,
I was
really?
reading
Okay.
the paper about convolutional neural networks and I
Yeah.
wasn't sure. They said, "Oh, this line implements convolution." And I
Uh
was
huh.
like, "How is that possible? It's like only 10 characters." And so
Yeah.
I asked ChatGPT, "Explain this to me." Uh, it didn't do a good job. It actually its explanation for that line of code was entirely wrong. It
Uh
said
huh.
that it outputs an array of or a matrix of ones.
Uh
That's
huh.
clearly not what that line does. So,
Yeah.
but that's just probably because it hasn't seen enough APL code in the
There's not
real
a lot of
world.
APL literature out there. Yeah.
Yeah, but I was also thinking, okay, let's say that you can solve that problem. Then going back to the criticism of APL that it's a write only language, the
Hmm.
reason why people say this is because when you when you read it, it's really hard to parse. So if you are inheriting some code that somebody else wrote, it's just
Hmm.
easier to obliterate whatever they wrote and rewrite that function than to try to debug it and get into their mindset of how they were solving that problem. And I wonder if you could solve that by actually just getting LLM generated explanations of what the APL code is so that
Hmm.
you can quickly get a sense of, okay, this is, I get what's going on here and I will edit it in such and such way rather than having to sit there and try to figure out what's going on.
That's an interesting take. I think my thought on that. Well, I guess we can compare and contrast here. Like I was
Yeah.
thinking of the APL code almost like a extendable rod, kind of like a shower curtain, a segmented shower curtain, or maybe segmented
Mm.
nunchuck, right? It's one of those things where
Okay.
it's like a pole, but like you pull it apart and it's like connected by a chain and then it turns into like a multi-segmented nunchuck. I was thinking
Uh-huh.
of like a line of APL like that. And then so if there was like some intermediate value that you wanted to inspect, you can kind of pull apart that segment and then maybe, I don't know, that segment that would reveal the intermediate data at that point, and so you can kind of
Mm.
explore that without having to like cut and paste the beginning part of it and then put it in the REPL to see what it does. And then I guess if I were to like tack on your thing in addition, like just explain to me like what it's doing here, right? And so
Yeah.
uh, but like I was thinking about it as, oh, maybe people only talk about APL as a write only language because we have bad tools for it. Like, I
Hmm.
think one of the things that people in the tools for thought, or maybe like Brett Victor laments about interact our computers as an interactive medium, is that we've mostly copied dead paper. Like, we think about it as paper. And one of the only ways that we broke out of imitating paper so far is that we now have infinite scroll. Like, we're like, oh, we can
Yeah.
scroll infinitely. Like, we're not constrained by the limitations of paper. Guess what? It's infinite scroll. But I think that's like a minimum bar, right? And so
Yeah.
Brett Victor's take was that, oh, okay, like text can be interactive. It could be an interactive medium in which you visualize the things that you're talking about. But the thing is, like, the visualizations that he had, while interactive, were still very labor intensive to produce. And so one step further is that if you have APL code that's a one liner but seems really terse and dense, I was thinking that you could like insert a probe somewhere in there and then it'll pull it apart and you'll show the intermediate thing. But in addition, from your perspective, you can just say, have it explain this part to me, or explain it step by step, right? And so what I'm
Yeah.
saying overall is that, like, maybe this is what interactive text is like. Like, you can have really dense and terse things, but you can have the computer explain it to you. It doesn't have to be right only, right? Right?
Yeah. Yeah.
And so there was a recent thing that was floating around the Twitter recently, was like it's an old blog post about a color coded explanation of the Fourier transform, and so it color coded the math for it. Uh,
Hmm.
So this is one thing that's been making rounds, but like most people find math notation to be dense, and so they're like, "Oh, math is too hard." But in actuality, it's just saying a lot in a really terse way, and it's a little bit more exact than describing everything in English. Because like if you've ever tried to look at math done before the appropriate modern notation, like it's way harder to read a description of it only. And so like imagine if you had like APL notation, like the Fourier transform that we're seeing here in math notation, and you're just saying, hey, just explain parts to me here. Like here you can see the combination of the exactness of the terse notation, like you get like how all the different parts are put together, and with the description of the Fourier transform, which is to find the energy at a particular frequency, spin your signal around a circle at that frequency, and then average a bunch of points along that path. You're like, oh, okay, like I kind of get what it's doing, right? And then the
Hmm.
devil's in the details in the notation. And so I think with interactive text, you could probably do something like that. And then APL and math can no longer have to be write only languages. Like they can
Hmm.
also be read only with the help of actual good reading tools, which are our interactive medium, right? Like we're still
Yeah.
imitating like dead paper with infinite scroll now, but like that's just such a low bar.
Yeah. I really like this because if you look at the graphic, it's color coded such that each part of the natural language explanation maps very clearly to the
The
mathematics
color
notation,
coded, yeah, which is also color coded with the same
which is
color,
also
yeah.
yeah, exactly. And so you can imagine kind of the combination of our two ideas about how to make APL more editable, which
Hmm.
is that you have the APL line of code. And you could do the same thing, right? You could get the LLM, let's say, or maybe it could be a
Right.
human written comment, but
Hmm.
nobody's going to write a comment, to be honest, right? So it's going to have to be LLM generated. But but the LLM could generate this kind of code, and you can imagine hovering over a part of the explanation, and it
Hmm.
highlights the part of the code that is doing that thing, and
Yeah.
then you can even incorporate your idea, which is that you could click that part of the code and you can see the data coming in and the data coming out So you get a
Yeah.
sense of what it's doing to the real data, right? And that gives you the entirety of what you need to know.
Yeah, and even more crazy, like let's say you deploy that and just see the live data streaming through, and then you can
Mhm.
either pause it or like run it backwards. Is that too much power? I don't know. But then maybe that puts a lot of observability companies uh out of business. Maybe not quite. Maybe in 20, 30 years or something like that. I don't know. Or maybe this would be regulated to a niche thing. And like everything, the solution to that popularity contest is that somebody needs to build $1 billion business on APL. And
Yeah.
well, maybe they already have. I mean, like K is already in production. Maybe they just haven't told anybody about it. I wouldn't be surprised if like K makes people $1 billion.
Well, my new thesis to go along with somebody needs to build $1 billion company for to take off is that somebody like Dan Abramov, the creator of React, needs to take this concept and port it
Port
to
it into
JavaScript
JavaScript.
and
Yeah.
not tell anybody what he's doing, and just and sort of like trick everyone into thinking that this is a cool new JavaScript library when in fact
Yeah.
it's just like some old idea that functional programmers or other computer scientists have been using for years.
The strange thing about computer science is that like in science fiction, usually like you would get a time machine, go into the future and steal future technology to use today. But
Right.
in actuality, what you can do is you travel to the past, dig up some like old technology that people failed to take notice of or like only a small handful of, and then bring it to the present and just port it to
Yeah.
JavaScript and make your fortune off of that.
Yeah, exactly. So I think it is interesting. It's intriguing, and also to go back to Iverson's principles for APL, we didn't really touch on this, but one aspect toward the end is that he mentions APL's amenability to formal proofs. In
Yeah.
that, yeah. So I think that that is potentially a good thing for instrumenting and explaining the code, as well as maybe even it gives you things like time travel debugging and all these things, because it didn't seem like there was a lot of mutability in APL. It seemed like everything
It looked like everything was functional, yeah.
was functional, and so maybe that allows you to, like you said, scrub through the history and see how data is flowing through it. It gives you a lot of observability advantage, basically.
Mm. Yeah, I think to expand on the amenability, I do want to dive into it too much in the beginning of podcasts. Otherwise, we'd be talking about this stuff forever. But I think one of the things about APL code is that since it's functional, you can find equivalent expressions, right? And so, due to any like laws like associativity and commutativity, you can manipulate it like math. And so, as a result, you have like a sequence of APL um, uh, single liners that when you chain it together, it becomes a proof because they're all equivalent, right? And so you can
Mm.
find equivalent programs like one liners, equivalent one liners, basically. And so that would be a way to do proofs.
Hmm.
So I think at the end of the day, languages like Julia, R, and MATLAB are probably better workhorses for the type of workload that APL or J would be used for. But you know that that said, I think there's different ways to expand APL if you want to go in this direction. And we talked about a whole bunch of things that I guess I wouldn't have thought of myself just looking at APL, but in discussion here, like we talked about, its relationship to interactive text as a possible language for that's good for LLMs to generate as a way for mobile programming to work, and like for data pipelines, for that matter. And in addition, I think if you're going to do programming language design, you should probably take a look at it also, because APL shows us we really don't know what programming is. And uh, and even if you aren't going to do programming language design, I think it changes the way that you think about programming, and the way that you'll approach problems there. And once you know that, you will tend to spot opportunities for something that is array like, and you'll find the so-called right tool for the job. So, and there are opportunities to expand products that you might use in different ways. Because I don't think I would have thought about APL as possible extensions to spreadsheets were I not to like look at it at all. So I don't know.
Yeah.
With that, I with the ecosystem APL, I'm not so sure, but I think the takeaway from APL and the core concepts that it tries to communicate, I'm pretty optimistic about that, and I think it should be in the vernacular and understanding of modern programmers, and it's really a pity that it's not, actually. So I'm pretty optimistic about the concepts that APL tries to bring to the table itself. What about you?
Yeah, very much the same. I think that every time we do one of these retro episodes, I think we try to strive for distilling what was the core concept or spirit of these things, less so the implementation, right?
Yeah.
And I think that APL is one of those things where it has this filter that on its face, on its surface, it looks absurd, and people get hyper fixated on just the surface level stuff.
Yeah.
And I think that my hope is that we've managed to capture more of its essence. And at least for me, now having seen it in that light, I see a lot of potential to carry on its spirit and make spiritual successors to APL, if not actually using APL in your daily life.
Yeah. So with that, I mean, my optimism is through the roof. Though we didn't talk about aliens this time. Like,
Yes.
I would say, like, my optimism is to the stars. What about you? Yes.
Yep.
Okay, so with that, our optimism and enthusiasm is out of this world. So if this episode opened your eyes, check out our other episodes where we talk about the other edges of technology and why they're interesting and what futures they point to. Check them out and subscribe. And be sure to check out our audio versions on Apple Podcasts or Spotify, and write us a review to help bring other Techionistas on board. With that, this is Will.
And this is Sri.
Signing off. See you next time. Bye-bye.
Bye.